To wrap up this section on projectile motion, before we get into uniform circular motion and a study of relative velocity, to wrap up projectile motion, I want to present you with a challenge problem. And this one's going to take a little effort on your part, but I think you can pull it off. So we've seen how we can use basic kinematics formulas to derive an equation for the range of a projectile that's launched across level ground. So if you have an object and you know the initial speed and angle, if you know v and theta, then you can derive a formula that says range equals v squared sine 2 theta divided by g. You can go back and watch a previous lecture where we derived that, or you probably can find that in your textbook as well. Okay, so here's the challenge. What if you have a case where it's not launched across level ground, but it is a somewhat like steady incline? How can you determine the distance along the incline that the projectile travels? In other words, you have this projectile, and you know the initial velocity, you've got v, and you have an angle theta, so how far that velocity vector v is inclined from horizontal. And then let's say you also have another angle. Let's say you have just the angle of the incline itself. So we got to distinguish between theta and phi, okay? Two different angles. And so you launch the projectile, and of course it takes on a somewhat parabolic path. It's more than half a parabola, but less than a full parabola. So let's label some quantities here. Let's say it has a displacement. I'm tempted to call it delta y, but how about I just simplify and just call that y? Okay, and the same thing, I'm tempted to call the horizontal displacement delta x. But how about instead, we just call it x? Then I'll add one more label and say the distance that it travels from the bottom of the incline to where it strikes the incline is some distance d. Here's the challenge. Prove the following expression is correct, that you can determine what the distance along the incline is, provided you just know three variables. As long as you're given the speed, the angle theta that describes the angle between horizontal and the initial velocity vector, and provided you know the angle phi, which describes the angle of the incline itself. Okay, now g, of course, is a constant. Here, phi shows up again, and theta shows up again. But that's it. All you need to know are v, theta, and phi. And those we'll assume are all given in a problem like this. I leave that to you as a challenge. The next posted video in this unit will be the solution if you want to check your work. But please do not go in and watch the solution. Don't watch me work out the derivation for this formula until you've exhausted your attempt to try to prove that on your own. If you can, then I'd say you've advanced to the level where you understand projectile motion rather well.